So before we tackle this question, let's just talk about what I represents. I is the square root of -1, because you can't find a number to multiply itself to make -1, right? If you think -1's the answer, well, if it's really the square root, you should be able to do -1 times -1. It should make -1. But it doesn't work, right? Because negative times a negative would make a positive. So that's why we use I, because believe it or not, imaginary numbers, having the square root of -1 actually helps us make some calculations. You know, as a math teacher, the problem with math teachers is that we don't have enough real-world experience. But you know, we've got electrical science. Imaginary numbers help us with calculations there. I'm sure there's lots of cool applications in engineering because you can represent some pretty cool functions. You can rewrite them using imaginary numbers. Sometimes it helps you solve a pretty complicated equation. Okay, so square root of -1, that's I. So what we look for when we're trying to simplify imaginary numbers is I squared makes -1. Okay? Because the square root of -1 times the square root of -1, the powers add up to make -1. Okay? Because a 1/2 power plus a 1/2 power makes a 1/2 power. And that one's pretty complicated too, because you could say, well, yeah, you can multiply that stuff inside the square root and it makes a positive one. But remember, the order of operation says that the idea of exponents needs to come first before multiplying. So that one's tough, but that's something that we can jot down in our notebooks, that I squared makes -1. And so that means I to the third, that's going to be -1I, or you could just say -I. Because I to the third is just I squared times I to the first, right? The powers would add up to make I to the third. And we just define I squared to be -1. And so I to the fourth, that's going to make 1. And again, you can break that up as I squared times I squared. -1 times -1 makes a positive 1. And now if you go to I to the fifth, obviously we don't want to keep counting until we get to 57, so we want to look for a pattern. But I to the fifth is I squared times I. So that's just going to make a plain old positive I. I to the sixth is I squared times I squared. So that makes -1. And then I to the seventh, let's see, it's going to be -I. And then I to the eighth is back to +1. Let's see, is that everything? Yeah, that's all we're looking for. Okay, so the whole point of writing these out is that you can see that if you just take the power and divide it by 4, whatever the remainder is, like this one is I to the first, right? Actually, we can just leave that. If the remainder is 1 on the power after you divide by 4, then it's going to be, it's just going to be I. It's just going to remain there. If you do the power divided by 4 and the remainder is 2, it's -1. If you do the power divided by 4 and the remainder is 3, then it's -I. Etc. Power divided by 4, and if there's no remainder, then it's 1. So here, look, if you do 5 divided by 4, the remainder is 1. That leaves us with I, just like our formula says. So what we really want is the remainder. If we divide 57 divided by 4. And if you do that, it makes 14.25, so this is 14 1/4, right? There's a remainder of 1. And we know that that result, when you divide by 4, if the remainder is 1, then your result is going to simplify to be I. And if you really want to check, you could just split this up into a bunch of I squareds. This is I squared times, or maybe even I to the fourth would be quicker, because I to the fourth is 1. And you could keep writing that out until all your powers add up. But you're going to have an I at the end. So 1 times 1 times 1 times 1 times 1 times I. So, in other words, this is I. If you get another question, like if it says I to the, I'm making up a number here, 743rd power, well, I know what that's going to be if I use that trick. Take 743, divide by 4, and that's going to have a remainder, that's 3/4, right? It's going to have a remainder of 3. And when we have remainders of 3, the result is going to be -1I. When they say they want this in terms of I, Look, this is the square root of 63 times negative 1, right? Because if you multiply by 63 by negative 1, it makes negative 63. So this is the same thing. And the reason why I pulled out the negative 1 is because that's the definition of the imaginary number, right? So that's our square root in terms of I. Sorry, I forgot. We want to simplify if we can too. And if you don't remember how to simplify square roots, that's when you try to factor out of 4, or factor out of 9, factor out of 16, factor out of 25, anything where you know the square root is a whole number. Okay? So with the square root of 63, I know, at least if you don't know, then you can suspect that maybe a 9 can divide into it. It works, right? 63 divided by 9 makes 7. So look, this is the same thing as this up here. But the square root of 9, the whole reason we pulled that out is because that's just a plain old integer. So this is the fully simplified version of the answer to the question.